Hey everyone, welcome! If you have ever used Claude through the API and suddenly noticed your bill going through the roof, this video is for you. Today we are going to talk about how to reduce your token usage in Claude without losing any quality in your results. Think of tokens like the fuel that powers every AI response. The more fuel you waste, the more you pay. By the end of this video, you will know exactly how to stop wasting it. Let's get into it. Before we look at any tips, we need to understand why tokens spiral out of control in the first place. Here is the most important thing to know about Claude: it has no memory. Every single time you send a message, Claude does not just read your new message. It rereads your entire conversation from the very beginning. So think about this. On your very first message, you might send 100 tokens. By your fifth message, Claude is processing around 3,000 tokens total because it is carrying all your previous messages along. By your 15th message, you could be at 15,000 tokens or more, just for a simple follow-up question. This is called the stateless penalty, and it is the root cause of almost every runaway token bill. You are not paying for your question. You are paying for your entire conversation. Now let's talk money, because the pricing structure has a hidden trap most people miss. Claude charges you separately for input tokens, that's what you send in, and output tokens, that's what Claude writes back to you. The big surprise? Output tokens cost 5 times more than input tokens across every model. So trimming a long, verbose response from Claude saves you significantly more money than trimming your own prompt. Think of it this way. Optimize the exhaust pipe before you optimize the fuel tank. On the screen you can see the pricing for Haiku, Sonnet, and Opus. Notice that the output column is always 5 times the input column. Keep this in mind for every tip we cover next. Alright, tip number 1, and this is the most powerful thing you can do. It is called prompt caching. Here is a simple way to think about it. Imagine you are a teacher, and you have a very long set of classroom rules you read out loud at the start of every lesson. With prompt caching, you read those rules once, freeze them in memory, and then for every lesson after that, you only pay a tiny fraction of the cost to recall them. In technical terms, you mark your system prompt, your documents, and your tool definitions as cacheable. Claude stores them. On every future request, instead of paying full price to process them again, you pay just 10% of the original cost. The numbers are incredible, up to 90% cost reduction and up to 85% faster responses. The golden rule is simple. Static content, things that never change, must come first in your prompt. Dynamic content, the new user message, comes last. One important warning: if you change even a single word in the cache section, the entire cache is invalidated and you pay full price again. So keep your static content truly stable. Tip number 2 is about cleaning up your conversation history, what we call context window pruning. Remember the snowball problem we talked about earlier? Every old message you carry forward costs you tokens on every single new request. The fix is simple. Keep only the last 6 to 8 message pairs in full detail. That is your active working memory. For everything older than that, compress it into one short summary block. Think of it like this. Carrying your full conversation history everywhere is like going grocery shopping while carrying 5 years of old grocery receipts in your wallet. You do not need them. They are just dead weight you are paying to carry. Also, whenever you switch to a completely new task, clear your session entirely and start fresh. This one habit alone can cut your per turn token costs by 40 to 70%. Tip number 3 tackles the output side, and remember, output costs 5 times more than input. The problem is that if you just say, "Explain the solution to me," Claude will give you 800 tokens of polite intro, formatting, and explanation before delivering what you actually need. The fix is to be very specific about what you want back. There are 4 tactical constraints you should know. First, specify exact length, something like "answer in 2 sentences" or "give me a bullet list with no explanation." Second, request structured JSON instead of conversational prose. When you are building something programmatic, it is almost always shorter. Third, use stop sequences in the API to cut Claude off the moment you have received what you need. And fourth, this is a pro trick, prefill the assistant turn. You start Claude's response for it, skipping the preamble entirely. The result? Instead of 800 tokens of waffle, you get 50 exact tokens of what you actually needed. That is the difference between paying full price and being smart about it. Tip number 4 is intelligent model routing, and this is where you can make truly massive savings. The idea is simple. Not every task needs the most powerful and most expensive model. Claude's models sit in 3 tiers. Haiku is the fastest and cheapest, perfect for simple tasks like data extraction, classification, or short answers. Sonnet sits in the middle, great for moderate coding tasks and RAG pipelines. Opus is the most powerful, reserved for complex, multi-step reasoning and agentic judgment calls. The economic impact here is enormous. Haiku is 5 times cheaper than Opus per token. The smartest approach is what we call a 2-pass classifier. You use Haiku, the cheap model, to first classify how complex the incoming request is. Then, based on that classification, you route to the appropriate model. The cost of that Haiku classification call pays for itself immediately, because it saves you from sending every task to Opus unnecessarily. Tip number 5 is one most developers completely overlook: the Batch API, which gives you a flat 50% discount on everything. The trade-off is simple. Instead of getting an instant response, your requests are processed within 24 hours. For anything that does not require a live user waiting on screen, this is a no-brainer. Think about nightly evaluation reports, CI/CD pipeline summaries, bulk document ingestion and classification, large-scale content generation, or offline dataset transformations. None of those need an instant reply. The rule of thumb on screen says it perfectly: if the user is not watching a loading spinner, the job should be batched. That single habit can cut the cost of your offline workloads in half, immediately, with zero change to your output quality. Tip number 6 is about something called adaptive thinking tokens, and this one can catch you off guard if you are not careful. Some Claude models have the ability to think through problems internally before responding, kind of like showing they're working. This is controlled by an effort dial that goes from low all the way up to max. The problem is that thinking tokens are billed at the expensive output rate, that 5x premium we talked about earlier. Even if the thinking is hidden from you in the final response, you are still paying for it. So if your effort dial is set to max for a simple task, you are burning money on unnecessary reasoning. The fix: tune your effort level down to low or medium for simple extraction tasks. Avoid writing system prompts that say things like, "always think deeply." Set strict maximum token ceilings to prevent runaway internal reasoning loops. And use targeted tool use triggers rather than vague. If in doubt, use a tool instructions. Tip number 7 is what we call prompt hygiene and pre-flight measurement. This is about cleaning the fat out of your prompts and measuring accurately before you send anything. On the hygiene side, remove every greeting and redundant rule-setting phrase from your system prompt. Lines like, "Hello Claude, please act as a helpful assistant," are pure wasted tokens on every single request. Replace them with direct, positive instructions like, "output only valid Python." No explanations. For RAG applications, only inject the specific retrieved chunks that are relevant. Never dump your entire knowledge base into context. Now, a critical warning about measurement: do not use third-party tokenizer tools like TickToken to estimate your Claude costs. They can undercount Claude's actual tokens by up to 35% on newer models. Always use Claude's own native count_tokens API endpoint. It is free to call, and it is the only accurate way to know your real cost before you execute a generation. Tip number 8 is about managing long agentic workflows, situations where Claude is running multiple steps automatically, like in Claude Code or automated pipelines. Here is the problem. When Claude uses a tool to fetch data, say a 15,000 token JSON API response, that entire response stays in the context window for every message that follows, even after Claude has already extracted the 3 fields it needed from it. You are now paying for 15,000 tokens of dead data on every subsequent turn. The solution is context compaction. After Claude has processed a large tool result and extracted what it needs, you replace that massive raw result with either a tiny truncated placeholder or a short summary. Use the SDK's sliding window conversation manager or the server-side tool result clearing feature to do this automatically. The insight is simple. Once Claude has ingested the information, the raw data is no longer useful. Throw it away. Tip number 9 is called Externalizing Context with Memory and Tool Search, and it solves a different kind of bloat. The wrong approach, what we call the monolith, is stuffing everything into your context prefix permanently. 40 massive tool schemas, 5 heavy reference documents, all sitting there taking up space on every single request. The right approach is dynamic loading. Keep a small, lean core prefix that is always cached. Then use the memory tool to store durable facts that Claude can retrieve on demand, only when it actually needs them. Use the tool search feature so that instead of giving Claude all 40 tools up front, it can search for the right tool when needed. The key insight here is simple. If Claude can fetch it through a tool, it does not need to live in the context window permanently. Externalize it and only load it when it is actually needed. Now let's see what happens when you stack all of these optimizations together, because the savings do not add, they multiply. Start with the Batch API for your async workloads. That immediately cuts your baseline cost by 50%. Apply prompt caching to the remaining input prefix. That cuts it by another 90%, bringing you down to just 10% of the original cost. Add intelligent model routing, switching from Opus to Haiku or Sonnet where appropriate, costs drop to around 4%. Layer on context pruning and compaction, now you are at 2.4%. Apply output length control and pre-filling, you land at under 2%. The final result, teams that apply all of these architectural levers consistently report over 80% total cost reduction, with zero degradation in the intelligence or quality of their results. These are not additive discounts. They are compounding multipliers, each one making the next one more powerful. Before we wrap up, let's lock in the 5 fundamental laws of token optimization that summarize everything we covered. Law 1. Cache the prefix. Freeze everything that does not change, your system prompt, your documents, your tool schemas, and mark them as cacheable. Law 2. Prune the exhaust. Actively kill context and tool results that Claude has already processed and no longer needs. Law 3. Route by complexity. Do not send Haiku-level tasks to Opus. Match the model to the difficulty of the job. Law 4. Constrain the output. Output costs 5 times more than input, so pre-fill, format, and limit every response. Law 5. Measure accurately. Always call the native count_tokens API endpoint before you execute a generation. Never guess. Never use a third-party tokenizer. These 5 laws apply to every Claude application, from a simple chatbot to a complex multi-agent pipeline. And that brings us to the closing message, and I want you to really hear this. You do not need to implement all 9 tips today. You do not need to refactor your entire pipeline this weekend. Just pick one thing. The single highest impact starting point for most teams is right there on the slide. Add cache_control type ephemeral to your system prompt. That is one line of code. Pay the small 1.25x write premium once, and from that moment forward, enjoy a 90% discount on every single subsequent read of that cached content. One line. Immediate savings. Then measure your results and stack the next optimization on top. The best token is the one you never had to send. Thanks for watching. If this was helpful, like and subscribe, and drop a comment below telling me which tip you are going to try first.